Hello and welcome to today's problem 22, generate parentheses. So given n pair of parentheses, we want to write a function to generate every single possible combination of well-formed parentheses. We're given two examples here. Example 1 is when you have n equals 3, so you're given the ability to create 3 open parentheses and 3 closing parentheses. And from these you want to generate all different possible combinations of them. For the second example, you're given 1 and equals 1, so you're allowed to create 1 opening parentheses and 1 closing parentheses. Okay, so just taking a look at this, looks like we have to generate all possible combinations, and there's going to be some trial and error involved if we were to generate these ones. So ones like the, ones that look like this. For example, this isn't a valid one, even though if we have let's say this one isn't valid. And we have to be able to check a whole ton of different combinations of ones which aren't valid as well as the ones that are valid. One way we could do this is by using backtracking. So what backtracking is pretty much just trying a whole ton of different combinations out, and then basically once you hit a dead end, you go back and try out different options. So we can use it in this case by basically having a stack. What we can do is have a stack, which basically this stack can contain all the different combinations, I guess our current combination that we've gone through so far. So for example, we have we have n is equal to a certain amount. What we do is we can generate one that looks like this, right, for n equals 1. And then we can also generate one that looks like this, an opening and a closing parentheses. Well, we know for sure that this one can't work because it's not valid, so this one has to be chosen. So let's think about the different kinds of criteria that we would need in order for something to for the stack to be valid at a given point. So one thing is that when you have an opening bracket, the amount of opening brackets has to be less than n, right? Because n is equal to 3, it has to be less than that, for sure, right? So number of opening brackets less than 3. Another thing we have to look out for, if we take a look here, is the number of closing brackets. Every single time you add a closing bracket, there has to be a matching opening bracket in order for you to do that, right? So at any given point, as you're generating these brackets, you can only generate a new opening bracket or a new closing bracket if the amount of opening brackets is greater greater than the amount of closing brackets. So I guess another way we could word it is add closing brackets if amounts of closing. Let's convert this to a variable in order to make this make more sense. If closed number is less than the open number, because if the closed amount is less than the open number, which for this one it currently is, let's say if we go on to the next iteration, then we're able to go ahead and add it and it'll be valid. So okay, we can run through this again. Let's have a look here. We have these two parentheses. Let's say we're trying to generate this. We start off with these two possible combinations. This one doesn't fulfill the second criteria, right? Because the amount of closed ones isn't less than the amount of open ones, the same, so you can't do that. That's not possible. So we move on to the next one, this combination. We take a look and we see, okay, number of closed brackets less than 3 valid, so we can add that. That's one possible combination, right? And another thing we could do is we can add a closing bracket if the amount of closed ones is less than amount of open ones. That's true because it's 0 and 1 so far, so then we can add that. And we can keep on going so on and so forth until it should, with these two criteria, generate that final answer. So yeah, just to reiterate how I'm going to go about doing this, we have a stack. We basically check for these two criteria. We add an opening bracket if it's less than 3, and we add a closing bracket if the closed amount is less than the open amount of parentheses. And another thing we can go ahead and check for is whether or not it's an actual valid solution. It's valid, is valid solution if the amount is equal to 3, so closed n equal to 3. And you also know it's valid if the open amount is equal to 3. And open amount is equal to 3. And you also know it's valid. Yeah, I think it should be this two criteria. Yeah, these criteria. So well, if it's equal to n and this one is equal to n. Yeah. So if these two criteria is valid, then pretty much we know that that is the valid solution because it's fulfilled all like both criteria, and it also has this as well. If it's a valid solution, then we can go ahead and append to a results array, which we can then return at the very end over there. So yeah, I'll go ahead and begin implementing this now. First, we need the stack, like we were talking about before. The second thing we need is the results array over here. We'll have results array, and we're gonna want to return that results array at the very end. And next thing we're gonna do is we're gonna want to make the backtracking method. So we have def backtrack, and what do we need? What's our criteria? We need to see what the closed amount is. So closed amount of the closed amount, the amount of closed ending parentheses. Yeah, the amount of closed parentheses and the amount of open parentheses over here. And then from here, what we can do is we can call the backtrack method, and at the very beginning, the amount of closed parentheses is 0, and the amount of open parentheses is 0 because we haven't generated anything yet. So from here, what we can do is first, we want to check to see if it's a valid solution. If closed amount is equal to the open amount, so or like the n, and open amount is equal to n, then we know that it's valid, and we want to return basically our final answer by appending it to the results array. So yeah, to append that, we'll just do res.appends. What do we want to append? We want to append the current stack at that moment. So we'll do this dot join the stack. So we'll join let's see, stack. Yeah, so basically this will combine every single element within the stack back into a string over here, like not separated by anything, and then I'll append it to the results array. So that's our first thing, checking to see if it's a valid solution. The next thing we need to do, like we said before, first criteria, we need to see if the number of opening brackets is less than 3. So if opening brackets is less than 3, or like I guess like in general case n, what we want to do is we want to append the opening bracket, have that as a case. So what we can do is do a backtrack. Want to backtrack with closed amounts, basically open amounts over here, and we want to be able to append to the stack.append. We want to append to the stack the opening parentheses because that's a valid one. So we can add this, and then we'll call backtrack on the method again to check for like any possible combinations for that one in the future. And then after that, we want to pop that element from the stack because we've already gone ahead and called that method, and we can check for that one. So pop that from the stack. Same thing with a closed bracket. If closed n, if its closed n is less than the open amount, then open n. Then what we want to do is append the closing bracket over here, do a backtrack on closed n and open n. So also what we need to do is, since we need to add the number of open parentheses by 1, since we've just added it here. And then we'll also do the same thing for this one. We want to add the number of closed parentheses by 1 by doing this over here. So at the very end, we'll pop that from the stack again. And then this should be valid. We'll go ahead and run through the logic one more time. So we have the results array, we have a stack, and basically we do backtracking starting off at 0, 0. We check to see, first of all, whether or not both are equal to n. If it is, then it's a valid solution, and you append that to the result stack, the results array, and then return. next thing you need to do is check for first criteria. Check to see if the open number is less than than n. And if so, then we append it, we call the backtracking method, and we pop it from the stack so it won't interfere with anything else. And then we go on to the closed amount. If it's less than the open amount, then we're able to append that item to the stack. We can call a backtracking on adding 1 to the amount of closed ones, and then popping that from the stack as well to make sure it doesn't interfere. And at the very end, it should return the array of all the possible combinations. So we'll go ahead and run this now as a quick check. Yep. Okay, so it's accepted. We'll go ahead and submit this just to verify again. Great, there you have it. So the time complexity of this method is going to be 2 to the power of n because it calls itself 2 times. If you have any questions, let me know, and thank you for watching.